Welcome to our last unit of the year, and it is geometry. So in this unit, we will be looking at the relationships between angles and the relationships between lines, rays, and line segments and how they intersect. So the first thing that we have to understand is what the difference is between line segments, rays, and lines. So if you look at the definition of a line segment, it has two endpoints. What I want to draw your attention to is if you look right here and you look right here, we have dots. That means this is a line segment. It starts here, it ends here. Now, if we look at a ray, okay, it has a starting point, and then it continues in a specific direction. So here's our starting point. That point doesn't change, and the line doesn't go on beyond there. Instead, on the other end, then, we do have an arrow. And this just means that it continues in this direction on forever. When you look at a line, okay, there are no endpoints. So when you look at how we indicate that, we put an arrow on this end and we put an arrow on this end. So that's the difference between a line segment, which has two specific points, an end point right here and an end point right here. We have a ray with one end point, and then it continues on in that direction. So this would just continue on and on here. And I know that's not a straight line, but, and then we have the line that, and this is what we've been drawing all along, which continues on this way, and it continues on this way, and that's indicated by the arrows. We are also going to be looking at angles. So if you look at this here, this is the space between where two lines intersect. So if we had to continue this line right here on this way, and we had to continue this line this way, we now have lines that intersect. And we've been talking about intersecting points and what they mean and all that kind of stuff. But we're now also going to be concerned with this space right here between these two intersecting lines. Okay? And that space is called an angle. Things that we should already know: the sum of angle ABC, so this is ABC, so this angle right here, and then ABD, that angle right there, is 180 degrees. These angles are considered supplementary. If we look at this angle, ABC and CBD, they add up to 90 degrees. And these angles, if you remember, okay, these are called complementary. So supplementary angles add up to 180, complementary angles add up to 90. You should already be able to also look at this diagram and choose the angles that are equal. So again, here we go. We have COB, or BOC. It doesn't really matter how you name it. And AOD. So these two angles right here and right here are equal. And that doesn't seem to want to work too well, but you get the idea. We also have then these angles COA and BOD. And those two angles are equal to each other. Hopefully you already know this as well. If you have two parallel lines, and in this case we have parallel line L, we have parallel line M, and then this line right here that goes between these two, that intersects both of them, is called a transversal. So this is a line that intersects a system of other lines. So our system is lines L and M, and P is the transversal, the line that intersects that system. Now, we are also concerned with the angles that are equal in this diagram. So if we had to measure these, angle B, this one right here, and angle F would be equal. Angle B and angle D would be equal. Angle F, we said, is equal to B and is equal to H. So now we actually have 4 angles that are equal to each other. So we have BD, which are across from each other, FH, which are across from each other, and then of course we have B and F, and D and H. And because of that, D and F are equal, and B and H are equal, so all those 4 are the same. We also have the other angles that are here that are equal. So if we look at angle A, we can see that it's equal to angle C. And we have E, and we have G. And for some reason it wants to make lines, but that's okay. Now, if we, same rules apply if we have angle A and angle C that are equal, angle E and angle G that are equal, G and C are equal, E and A are equal, so they are all equal to each other. Fantastic. Now I want to look at some definitions. So, what do we call these angles that are equal to each other? We have interior alternate angles. So if we look at interior alternate angles, these are angles that are in between the parallel lines, are on opposite sides of the transversal, and are not adjacent. So it would be something like angle D and angle F. Interior alternate angles. They are in between the parallel lines, on opposite sides of the transversal, and they are not next to each other. Okay. Next, I want to point out exterior alternate angles. These are angles that are outside the parallel lines, are on opposite sides of the transversal, and are not adjacent. So now we're going to look at outside the parallel lines, on opposite sides of the transversal, and not adjacent. So opposite sides of the transversal, outside the parallel lines. If we look at corresponding angles, these are angles that are in the same position on both parallel lines. So both are below one of the parallel lines and right of the transversal. Okay, so angles that are in the same position on both parallel lines. So things like B and F, exact same position on both parallel lines. They are on this side of the transversal, or in the exact same spot. Our last definition are co-interior angles. Co-interior angles. These are angles that are in between the parallel lines and on the same side of the transversal. So angles in between the parallel lines and on the same side. So that would be angles, and let me just get rid of this, in between the parallel lines on the same side. So this angle and this angle. It's this whole set right there. Okay, so again, C and F, and those are called co-interior angles. As a summary, we have supplementary angles. These are two angles that add up to 180 degrees. We have complementary angles, two angles that add up to 90 degrees. Opposite angle theorem, which I didn't even tell you that's what it was when we did it, but opposite angle theorem is this angle here and the one opposite of it are equal. So BOC is equal to AOD, and BOD is equal to COA. That is called the opposite angle theorem. We also have parallel line theorem, which means A is equal to E, okay, B is equal to F, C is equal to G, and D is equal to H. If you're using that to describe something, you would say that's the parallel line theorem. A is equal to E because of the parallel line theorem. B is equal to F because of the parallel line theorem. The other thing that we haven't talked about yet, sum of the angles in a triangle theorem, or SATT for short. What that means is if you have three angles, any triangle, it doesn't matter what the shape of the triangle is, all three angles will add up to 180 degrees. And we will do a little bit more work with this in the next lesson or two. That's the lesson for the introduction. If you want to go back and replay it again, please by all means do so. It will be posted on the MyClass website, and you can actually go back and listen to it at home as well. And on to the next lesson.